So there is a duplicate material in this, and I have the slide deck is pretty detailed. I wanted to go over use cases and how to use it and how to build and so on. So for this discussion, we could focus on framework depending on interest level in terms of most of you probably know how to run it anyway and then build and such. So if you want, I just wanted a detailed slide set, but on the other hand, we can focus on based on interest. Oh, okay, okay. That's okay. I can. Yeah. It'll be fine. Please bear with me. Yeah, I figured So where are we? Well, you saw this slide in the, it's just, Kselftest is I consider this as a regression test mainly written by kernel developers and used by kernel developers to test their features and so that there are no regressions from release to release, especially when we add new features or new flags or extend a feature. That's when there is a danger of regressions introduced in the existing ones. So that's mainly, and so it's a unit test mainly. I consider this to be more a white box type test. Developers know what they want to test and what they want to do. So it has that's how it evolved, put it that way. So we have been in the last 40s, we have been trying to get it to a state where it can be used as well, not just by kernel developers, but it can be used in test rings and also in automated test environments, and so that it's just that has been an evolution of where we are going with it. So currently it does get run in Linaro test forms, 0-day and kernel CI to a limited extent. And then Linaro test forms have been using it very extensively for last year, I think, correct me if I'm wrong. And what Linaro test engineers have been doing is they'll run it on all stable releases that come out. And then they also run it on Linux stacks, Next, and mainline. And then stable releases, for sure, they'll run them and they'll send them up, all the results each week. And then they're very detailed results in the sense that they'll report if there are any regressions or if any test that should have skipped, failed. So we have made lots of improvements based on the feedback in the last year. So dealing with how to deal with mainly the cases of what do you do when a particular kernel configuration is not enabled and you run a test. And then also you might have a kernel configuration enabled, but maybe a specific feature is not enabled within that. So those are the kinds of things we, in the past, before 4.18 and 17.18 timeframe, those were, we just reported them as pass, which is bad, because you're giving wrong impression. So that kind of evolved to say, hey, let's not do that. We can't fail them either. That's also a wrong indicator. So I went through and made lots of framework changes, and then also I updated probably all of the tests for 4.18 to report correctly. Now, since 4.18, we report skips correctly. And twofold approach, because one is if there are C programs, we have a bunch of tests. We have shell scripts, we have executables. Shell scripts have their, you have to update them as well for skip handling. And then also C programs. And one of the things I have done is to make it, a lot of it is abstracted from the tests themselves, because I'm handling a lot of these things in the framework. as you know, all of this framework is mainly make-driven, right? Make file hierarchy. So here, let's talk a little bit about framework. So framework is where a lot of the magic happens in the terms of how building gets done. And we have makefile, main makefile, where all the targets are listed. Targets for default run are listed. So when you're adding a new test or a new test that doesn't exist, then you have to go and add it to the Kselftest makefile, which lives under tools, testing, self-tests. And then after that, once you add that, you pretty much, you don't really have to, as far as in the make file, you don't have to do anything. And then you can lib.make, lib.mk abstracts a lot of the common code targets. So it'll, and then Kselftest.h abstracts both pass, fail, skip conditions, and then also tap test anything protocol reporting. So if you are running, say you're running a C test, then you would go write your test and you say, hey, a simple example would be your test needs root to be run as root. And the first thing you would check is, well, am I running as root? And then you would say, I'm skipping this test and use the Kselftest skip API and say, print a message and say skip. So that automatically gets counted. And then says how many skips. It also counts the number of skips and pass and fail. If you, timers probably is one of the examples. You have multiple tests within a test, then they get counted on how many passed and how many failed. So there are install and tar package, packaging tool, both of them. They support various, it's very similar to what some of the tar archive stuff that we have in the kernel scripts. So one question that came up was, why don't we support Debian? I have Debian packaging. I didn't think that we would. Do you have any ideas on whether we support Debian packaging for individual kernel pieces? No? Right, okay. Okay. So reporting results, this is one of the improvements that came about from users asking for, hey, we want to be able to parse them using external parsers. So that's when a simple text-based interface test anything protocol, what it is really, I'll show you some examples of what the output looks like. It's if a test is passed, it'll always start with okay, meaning that's an indicator that everything passed. And if a test fails, it starts with not okay. So easily parsable from run to run, as well as external parsers, tools. So use cases. These are the use cases I wanted to put. People keep asking me, so can we run, should we run the same, do we match kernel to the self-test release? Self-test in the same Git. So I'll always say, for better coverage, you want to run mainline, but it comes with its own caveats, because every time you run mainline, there are new tests added to the mainline. Some of them might not be handling skip and unsupported cases correctly. You might see failures but they get all fixed, but depending on what you want to do. But generally, if you run the same Kselftest that comes in the same release match them, then the coverage, it is because of this reason. Because we keep adding more tests. Because we also cover features that existed in the previous releases as well, as we keep adding. Cgroups is an example. Cgroups just came in a couple of releases ago. But Cgroups, we have had Cgroups for a very long time. So if you don't run If you, okay, so if you ran 4.10 self-test on 4.10, you're not taking advantage of the newly added C groups. And source is, like I mentioned already, it's under tools, testing, self-tests. So here is how I maintain the Linux K self-test kit. I usually do have a fix. A fix is pretty common across. I mean, it's the same model that everybody else uses. Fixes and next. I tend to put more stuff in probably next and then fixes, depending on when the tests come in, or fixes go. I send up right away. And then there is also Patchworks project to kind of track, archive. There is documentation under dev tools. It's after we did the documentation directory re-architecture, they ended up in under dev tools. I also write blogs once in a while when something big happens, like I do a tap handling, tap 13, or we introduce framework changes. They usually go to, Samsung hosts a open source blog site, so that's where I usually write them. So building tests. There are multiple ways, because of the way it evolved. Self-test evolved, they already existed before developers are used to running self-tests a certain way. So all of those use cases, backward compatible, I try to support them. You can run all tests from the main make file. There are multiple ways to do it. Make K self-test will just build and run all of them. But if you don't want to you don't want to run and build in one step, you could also just go and build them with make-c and at the top level make file. And you can also build individual tests, like timers is I'm showing here, but any other directory you can do that. And you can cross-compile on usually the same way you would cross-compile any other kernel component. So silent does help you. You probably notice silent there. I always run it with silent because there are a lot of extraneous makefile messages that come out. So I tend to do silent on mine when I build them. By default, if you run make K self-test, it will run all the targets that are listed in the makefile. So there are other tests that don't get run in default, partly because they aren't suitable for a default run. They might be destructive to system or change the system state in a way you probably don't want to do unless you're really aware of what you're doing. So a lot of these tests, if you just did make K self-test without being root, then a lot of the tests don't get run. So you have to, for good coverage, you want to run it in privileged mode. You can also use targets variable, which is, it's very convenient. Sometimes you're changing just one test, or from a developer perspective, if you're changing just one test, you don't want to sit through the entire test run. Or maybe you ran K self-test and you found to one of the tests that might have failed, or you want to examine that test a little bit better, or output. You can just use targets variable. And then you specify a list of tests to run, or those are the only ones that get run. Make or relocation, it's not perfect yet. Andrews mentioned that it doesn't do relative paths, so there is some work to be done. But this work I did last year. And then it does work if you give the full path, but it doesn't work. But you can relocate the build to another directory. And also running also happens there, because you actually are running out of the directory that you built. So this all happens, all of this happens with the common framework magic, like I said. So it'll copy all of the, it'll build in a relocated directory, and depending on how you're running the test, it'll try to copy minimum needed to run the test. So there are some tests that require, for example, some data files to be present. So they need to be, in some cases, copied, test programs. I'll get into framework test variables, variables that get used, but later on. You can also run individual tests. Individual tests can be run in different ways. Actually running them, earlier we saw how to build them, but you can run one single target by using run test target. Run test is a makefile target, really. So it's the one that goes and runs the tests. So these are multiple different ways to use these, run these tests. I think I'm going to go, if that's okay, I can go past these because I think you have the slide deck to look at. So a couple of things I want to mention is default versus stress testing. There are some tests, like for example, hot plug, CPU and memory hot plug, and pstore tests. They support stress mode. That means stress and default mode. Kselftest runs them in default mode. That means if you have, it'll only try to, if you were to, when a CPU hot plug test is run, only a percentage of CPUs will be offlined. If you want to test the full extent of offlining maybe 80% of the tests, 80% of the CPUs, then you want to use the run hot plug target. There is another target to run. So you'll see that in the make file. There is a run underscore hot plug target and the main Kselftest make file. So you can run that. Oh yeah, I do have the slide showing the run hot plug. So you can run individual, run pstore crash is a destructive test, stress test that you can run. And timers also has a destructive test mode where you can run just all the timer destructive tests. So this is, there is two modes for reporting. One is a summary, and some users don't want to see individual messages, as opposed to when I'm running it, I want to see the individual messages that are coming out from the tests to see what's happening. But so when there is a request for can we just see the summary, I added a summary flag so that it suppresses all of the test output from the test itself, and it'll just print the summary of results, like, okay, these, how many passed, how many failed. I remember you ran into some issues with the summary mode. You weren't seeing, yeah, okay. I thought we talked about it, but anyway. So this is what it looks like if you run sync test, which should be run as root. So if you do that, it'll show up and say, hey, we should run this as root. So when it actually summary, okay. So we are still running this in summary mode. So you can see the difference between the two. See how it'll tell you it should be run as root. So you won't see that message. To me personally, it's not useful, summary mode. But some users just prefer that mode. So they want to just know. They don't care why it failed, what happened. But to me, it's not a useful mode. And Also, if you're reporting a problem in the subsystem I'm maintaining, and a test failed, I don't want to see summary though. I want to see full results. I think that goes for all maintainers. So, so if you run sync test and say, hey, I'm in root mode, it'll do a bunch of these tests. It's actually running. You can see how it's counting the number of tests, like 1.10, 1 dot, that's a tab 13 notification. So main test, dot, the subtest number, and how many were run. So you will see that here, you'll see, okay, 1. So it'll also tell you which subtest it's running. And then the last 1.1 is the main target. That means we ran sync tests with several subtests that we ran within that. This is another example of a test. The previous example I showed you, a test with test cases within that test, whereas this one is multiple tests within the main target. Like this particular one runs a, in this particular case, this is looking for a test printf module. It'll load the module, it'll try to find the module. If it's not built in, if it's not compiled, then it'll skip. So it's not, it can't run the test, so it'll skip.
Yeah. Yeah, this is one of the good features. We are getting the advantage of it.
Okay, great.
Thank you.
That's, yeah, I think several people requested that we wanted to see the skip, you mean? The skip part? Right. Right. So yeah, I went and made modifications to almost all the tests to get this happen. In 4.18. It wasn't bad. I mean, you know, I just had to go make sure the cases, different failure paths. So install, Kselftest install, you can install to a location, and then default install location is right under Kselftest. I mean, self-test, and it'll install right there. And then you can specify an install location. It's, by the way, it's this install, there is no duplication here. It is taking advantage, it's running on top of the make, whatever we saw now, run tests and then building, there is no duplication happening. It just uses the same infrastructure. So it'll call all, when you run this Kselftest install.h, it really is running, make a Kselftest install, which goes and invokes all the build and install targets in the makefile hierarchy. And then another thing it does is, because when you're installing, you're running from the install location, it also runs through the emit tests. Emit tests is a way, say for example, the previous slide, what happens here is all of this logic in some cases, like module loading and such, need to be run as a shell script when you are installing. So it generates a consolidated, comprehensive shell script, run kself.sh, which gets run when you run from the install. So, but we are not really, there is no, it creates a run kselftest.sh because you don't want the output to be different from when you run it on the target, well, the same system that you built tests on and running via the make infrastructure versus when you go and install somewhere. It should be the same. So it takes advantage of, that's why it leverages the make hierarchy and doesn't come up with its own script. It actually uses the same common. I actually went and found some duplicate, and then I made it common A lot of it, emit tests, there was some duplication, so I actually now use a common routine to print, do the run. So you can package it, and then you can package the entire, but then you're building outside the kernel, so you have to figure out headers as well in that particular case. Any questions so far? I want to. Building and packaging. So you can build and install that's what it is, right? I mean, you're installing and you can tarball that. This is for people that want to maybe run it on instead of cross-compiling and installing. If people want to copy it to the target and then run. So I don't know how many people are using this though. Don't know.
We are like cross-compiling and make install to create a tar file. So that tar file will be exported to the target under the test. So then we are testing there.
That would be that's really a good way to do it, because I mean, otherwise you have to figure out build tools and so on. So, and like,
just to mention that, I think that's pcap, libmount. There are 3 or 4 userland dependencies right now. So if you cross-compile, you lose the headers for those, and then packaging turns into, so I'm doing inside containers. I'll be talking about a little further, but that's the idea. So that's the depending on userland right now for cross-compiling is not so good.
So the packaging, this packaging tool I did based on a request from, I'm not sure, kernel CI folks, I think for the same application, QEMU or containers, they wanted to be able to install there and just take the sources and compile. So, I mean, I think it's used.
One question. So when you build today, are you using a OE recipe to take care of all this already, or? Which
recipe?
Are you using, do you have an OE recipe, a Yocto recipe to build?
The build is in the thing. The build infrastructure is part of the...
No, but you're saying you're cross-compiling, right? And creating a tar wall.
Yeah. You can, okay, that's a question
for
you.
Our case, yes.
Yeah, I was thinking, okay.
In our case, yes, we are building an OE recipe.
Oh, okay. Yeah, because he was mentioning that there were some dependencies, some headers that were missing, where we should be handling that in the OE recipe.
Yeah, we are doing that. So he is referring to the Debian way of testing.
Oh, okay.
So some of the helpful hints over time, after playing with it for a while, I found, I mean, obviously root will increase your coverage, and then just beware of disruptive tests that might, in some cases, might require reboot, pstore crash or one of those things. And then running Kselftest from mainline kernel on stable releases is recommended. That's what I recommend. For a couple of things I mentioned, like C group getting added, or new tests getting added continuously. Go ahead.
I was curious if you have a sense of the percentage of tests that get run in the standard run versus the overall number of tests.
Oh, so the ones that are left out?
Yeah, like kind of what's in the standard safe run, what is the actual coverage of all the potential tests?
I have a slide down here somewhere, okay. Because I put together let me see. So I do.
The one I remember is denotified test case. So that's the one, like, it's while one test case. It never exits. So those kind of test cases we are not really running as a default.
Yeah. Well,
there are very few test cases we are not running.
Well, so part of the thing is, at least with like the timekeeping tests, I know, the make destructive tests, they're not super destructive, but it's just one of those things where they're not totally safe for somebody who wouldn't expect it. So.
All right. So to answer your question, as of 4.18, I tagged, these are all the tests that are in there. I tagged the ones that don't get run as default. So on this page, you see IS64. I mean, I don't think anybody is maintaining it. I haven't really gone and looked what the state of the test is. Networking, that networking is not it's not, don't confuse this with net. Net is where all of the networking tests live. This networking thing came in when I went in to documentation directory and looked for code that is kind of orphaned, and I moved it all under self-tests. So there are some tests, useful tools and tests that got moved, and I have been slowly going and looking at it and see whether it makes sense to keep it or makes sense to merge it to others. So that's one of the networking targets. And so that doesn't get run. And NTB, again, the same kind of thing. I moved it from documentation, and I haven't had a chance to go take a look and see what, if it makes sense to turn it into a test.
Well, it requires NTP hardware, which most people don't have.
Some of them, yeah, right. Some of those are hardware-dependent categories. So those are the ones that we don't. And RCU torture is a good example. It gets run, by maintainers, but maintainer does not think it should be included, or it's ready to be included in the default run, and we are kind of waiting on that.
That's just because it takes very long, right?
Correct.
Yep.
It does take long, and then, so.
So the Spark 64 test, why is that in the default set?
Spark 64, there is a driver under there, newly added driver test for ADI. There is a new feature that went into Spark for memory, so.
Right, but it wouldn't do anything on most architectures.
Oh, sure. Yeah. So it won't even get built.
Okay.
It won't get built. Any of the Spark specific, like PowerPC. PowerPC won't get built on x86 or ARM. And same thing with Spark. So, yeah. So does that answer your question?
Sort of.
There's very few. I mean, you can already count, it's a handful.
Yeah. I mean, I guess one of the things that I've been thinking about is, so at least with the timers test, the destructive test is something that, I would like to find a way to get more people to actually run.
Okay.
But it's not just something that I want people to trivially just,
Trivially
run in and, oh yeah, no, I'm just checking this. I mean, it does add extra time to it, that sort of thing. I feel like in a couple of the other cases where we have these other stress tests, they're all sort of hidden or secret tests to some extent from the external view, and they're a little balkanized in what command actually runs it for which test.
Right.
And so I was wondering if there's been any thought about kind of trying to maybe put in some certain levels of testing across all the tests, where you could say, okay, well, I just want the simple, quick ones, and then maybe the long-running tests, and then maybe the tests that, can change system configuration in ways that maybe, we don't want everyone doing, but is relatively safe for a continuous run, that sort of thing. Because, I mean, on most of the test hardware we're running in Linaro, the destructive test for timekeeping would be great to run, but it just doesn't usually get run, so.
Right. Right. I mean, it's easy to do. It's just a matter of having that, introducing a way to run a cross-section of tests. Yeah. So now we have evolved the framework well enough. I'll talk about that it would be easy to do. Sometimes it's a matter of deciding. One of the things I run into is I can't tell. It is a maintainer, individual test maintainers and authors have to decide on, I mean, that's what I need. Yeah. We need input in that. Or I just go and say, hey, I provide the framework and say, you guys make changes as you see fit. To me, I like not to do that. I don't like to go, that's why I could have easily done that with skip. And I could have said, hey, I'm adding a skip, you guys go make changes. But somehow it just doesn't, as a developer or maintainer, it doesn't feel right. I want to be able to just, So if it's easy enough, I just go do it. And then I get reviews from people. But some of this stuff, I won't be able to tell. Like, for example, you come and say, hey, these are the destructive tests, then that'll be helpful.
I've got one more question for a previous slide where you said that it's now recommended to run the latest released Kselftest on a stable kernel. I remember that we had some long discussions about that when we initially tried it, and some maintainers said they really didn't want their tests to work reliably on older kernels because they didn't want to have to be bothered with making sure they do. Did that change, or do you still skip a couple of tests on that?
So we're kind of skipping, either ignoring, skipping a couple of tests.
Okay, but it's only a few of them, right?
It is mainly, I think, if it's a BPF tests, folks that didn't want to take that additional overhead of supporting them. And then I can see that. I can see that for that particular test. Maybe it's not applicable to that particular test. But I recommend for the other reasons of, as we are adding more tests, we keep adding new tests. So that's why.
That's been a problem for us, and especially BPF. Like, there's a bunch of new tests every release, and they all fail on older kernels, and we have to go through and do stuff afterwards to make sure that, to deal with that. It would be really nice if, even if they don't support older kernels, if they just skipped for older kernels in some manner, whether it's because BPF didn't exist or whatever.
Right. So
rather than just ignore the problem and let them all fail. That's
yesterday we were discussing about the runtime detection of the kernel version, and accordingly took a decision to run it or skip it.
I don't think a version check doesn't seem like the right answer, but like a function check, you know, some acknowledgement that this kernel may not actually have this feature.
That's what we do for all the other tests. It's
Right.
just that the folks working on that argue that it would be a bad idea in general.
Yeah, I mean, if they don't want to do it, we should probably have something in the framework that you can flag, you know, these maintainers are not into this. And, you know, so that then the tools can, the automation can know that it's running on a non-native kernel and do the right thing.
BPF also has more complexities in that it requires, for runtime, it requires Clang and such. So it's a little bit more extensive beast. So that I understand that's a pain point for you for the test strings. At the same time, I'm trying to balance here, because they want the tests. They don't feel like they have the bandwidth to enhance the tests, and that's something maybe we need to look into. Maybe if we can help move the tests, but as a principle, looks like they don't want to support it. And you know, I don't know where that falls, because either it's it could be the pain point that they have to continue to support, or it could also be, yeah.
I think it's going to be the same sort of sentiment here. It might help if, as a framework, we impose that for any new tests that come in for new kernels, if they can't support old tests, they should at least gracefully skip. I agree with you in that for existing tests, if you want them to go and change everything to do some sort of a detection, it may not be prudent. But for anything new that they add, at least if we can mandate that.
So for that for that particular subsystem, overall, that's what happens. That's a requirement. It's in the documentation as well. When do not. That's very clearly stated in Kselftest RST. Whatever it is, .text is easier, it rolls off my tongue easier. But it's there. I mean, you're not supposed to regress. You're not supposed to regress the test builds and such. It should continue to build and run. And if your test fails, it should shouldn't stop the run from running. And the second thing is that if architecture awareness, that means if a test does not compile on another, it shouldn't even try to compile on another architecture like Spark 64. It should not. And if it does, it's a bug that needs to be fixed. And third thing is that if a test is running on a kernel that does not support the feature, or even dependencies are not met. Sometimes you might have everything. You might not have the dependence. You might not have the right mount point or C groups probably, could be an example. So, or some other EFI wars, I think. You need some kind of mount point. So if you don't have that, you don't want to fail the test. You want to say, this is the dependency that's not met, and then I'm skipping. So it's clearly stated. So that's not a problem. The problem is when a test suite, BPF kind of a large test suite that has been maintained outside for years comes into self-test. Sometimes it's a trade-off. Let's add and fix problems. And whatever problems. It's like, I guess it's similar to probably what happens in the staging area of the drivers, right? So it's not to that extent, but staging we just completely ignore, but a Kselftest we can't ignore. We want to run them. So, so that's a good point, that if the same subsystem, BPF for example, came in, and then we're adding new tests, we want to make sure. And then I rely on BPF tests and then also net tests and tests. They do not funnel through my tree because of the dependencies. Because it makes it a lot easier on everybody if I don't insist that. And if I say, hey, let's let them go through whichever. So as a result, sometimes what happens is I might not it might not be on my radar, because I look at the test and then I review. If something really glaringly stares at me, I will give reviews, do review and send it. But in some cases, I might not pick up on all of that, and then they end up in the, so. And then they we just have to fix them. I mean, either you send me reports, and then I'll work with the developers to get that fixed, or I'll go fix it if I have time. Or you guys send me patches. There is always that. So how are we doing on time? I do want to leave some time. Okay. Okay, all right.
I had a high-level question about, so over here. So I get the sense, I guess, that it's a high-level mission statement for this as opposed to LTP, that this is meant as more of a quick smoke check, where I guess LTP is a more extensive, thorough thing. So what is the time, what's your overall time target for the default set of Kselftest to run? What are you trying to keep it around or under? And then how do you, I guess over time as the tests grow, right, we're going to have to become more and more selective, I guess, about what goes into the test suite so that it'll fit into that time target. And I guess how do you see that process playing out?
I don't have a set time target. At one time I started out with 10-15 minutes, but I don't. Partly because it's not because tests are taking longer to run. We have a lot more tests to run. So, so that's part of it. That's part of it. So, and I also think that, okay, if some developers say changed or net, they have a way to run just that one. We're providing multiple ways to run it. So you could pick targets. You can create your own target list and in your environment and just run those. So I see downsides to saying it has to fit into a certain time frame. So that's kind of how I'm playing it at the moment. And it might change. If it starts taking 2 hours, maybe we'll rethink that, but we're not there. I think it runs the entire test. I'm sorry. Yes. I think when I tested it on x86 a couple of releases ago, the entire thing ran. It took longer. I mean, it's not a coffee break, but it took about, I was timing it, I think it took about 30 minutes.
Would it help to add like I don't know, a quick 10-minute target, which just does that 10-minute thing, quick sanity?
So it depends what you want to do. Because of the number of targets now we have, about 45, 46, it'll be a lot of effort to go through and figure out what are the important tests to run. Because you want it useful also when you run. I mean, even a 10-minute test needs to be useful.
Yes, but that you could sort of delegate to the subsystem maintainers to tell you, give me 5 tests or tests that run under a minute, and I don't know, some mechanism of doing that.
It's possible. It's just that classification might be difficult to do.
I think the main reason where the timing comes in is when you do a lot of automated testing, and you want to have a timeout where you decide that something bad happened and this is never going to complete.
Right, right. Agreed, agreed. So, yeah.
And I don't actually know what we do at the moment.
So do you run into that issue of?
No, about the timeout, can we cancel it? But because it's a kernel self-test, so that sometimes it's broken in the kernel. So yeah, if hopefully we can cancel it, let's say break it, the test cases. But sometimes the test program broke in the kernel. So in that case, it's hard to break it.
You're talking about some bugs that might, kernel bugs that might, those are, I mean, we do run into that sometimes. A new test comes in and it hangs or something, but we do, I mean, those are kind of the problems, temporary fixable problems, not like what Arndt is saying, like how do you tell the difference between how long, because we're continuously adding tests, we don't have a time limit, so it's hard to predict. Did I answer your question that you have?
In case of F-Trace, we have seen test hangs forever.
Right.
So those are the problems we have seen. Like that's the case you're referring to, you know. If runs more than 10 minutes, then just kill it. So that's the way we need an extra framework on top of it. Currently, it's just a couple of shell scripts and test binaries to run. So if it is like LTP grown-up test case with multiple frameworks, then probably we could get there one day.
So I want to quickly go through contributing to tests, because that's, I don't know if it's of interest to people here. There is a make file when you are, or we can continue the discussion we are having. We have about 6 minutes. So, right. Okay. So, contributing to new tests. I look for these. Are you reporting pass and fail conditions? And then if the test, even part of the test, so this is what I recommend. You have a test. Couple of features that you're testing require privileges, but rest of them can be tested without. So I would like to see only that part skipped, if the feature. Rest, run as many tests as possible until you need root access. So that's kind of requires some conscious thinking when we are writing tests. So I want to build not breaking on any architecture. I do run into it sometimes, and that's okay. I mean, that's the process. We find problems, we fix them. And that Kselftest shouldn't break if a feature is not supported. I mean, if a test doesn't fail gracefully, and then we don't want that. We want it failing gracefully. And unmet dependencies, or that said, that's also, this happens quite a bit for me. Sometimes when somebody touches a framework or something, regressions and use cases, because not everybody goes and makes sure all of the use cases work. So I kind of go check once in a while that new tests are coming in that don't break the use cases. Because backwards compatibility, I want to be able to continue to support targets, for example, being able to pick and choose, somebody making changes to a few subsystems, being able to run those subsystems selectively. So how do you hook into it? So as when you add a test, if you decide first, well, hey, should it be run default run? If it is, just goes into the make file, gets added as a target. And then leverage common framework, I mean, for reporting. Because if you don't leverage common framework, we have to do whole duplication effort of all the reporting. Now it's all set and it's common. So you have build, running tests, installing tests, emitting tests. Emit tests target comes in when you're generating, when I'm generating the run Kselftest script. And then clean everything. I mean, don't override unless you absolutely have to. Know why you are overriding and then override. And then also config file. In some cases, if you add the config file dependency, then it goes under, like for example, it goes under the main directory. You might have subdirectories under Android, but just put them in the top. Combine them all, because you might run all of the tests because under that directory, so you might want a merged config file at that point.
So you're making it as a document trace fed?
Document what?
Is it been documented for a new test cases for a Kselftest to be written? Like it's kind of a guideline if there is a need of a case config, so that has to be added into the config.
Yeah, all of that is in the documentation file.
Great.
Andrews went and added the config recently. Config when he found that. So we are keeping that updated. So, okay, so variables, it's very important. This is something that you have to pay attention to. There are comments in the lib.make.mk file. Test gen programs are primary tests. There are custom programs that need custom rules to build, and that common framework does not build them. And test gen programs extended, well, it gets all confusing, but this is how it works. Don't ask me how we came up with this, but right now that's what it is. Run by primary tests. That means, I mean, it kind of makes sense, right? Just test gen program and then extended ones are the ones you have a test, main test, and it invokes another test. That test doesn't get run directly. It gets invoked by a test. So that's why it's called extended, run by primary tests. And test gen files are also run by primary tests. So if you get this correctly in your makefile, test makefiles are very simple. You just have these defines, and after that you're all set. So that's where we are with the framework, so which is really good. That's where I wanted it to be. So test programs, same thing. These are primary shell scripts. And then test programs extended, or scripts, either there could be executables or other scripts that primary shell scripts run. And test files are the data files. So what you do in your makefile is you're just gonna define all of these. It's just as simple. What is built by lib.mk common compile rules? Test gen programs, test gen programs extended, test gen files. So all three of them. There is a distinction between test gen files and test gen programs. I don't remember what it is, but it's needed. So test custom programs. Some custom programs need, sync is one example, or not sync. There is, I don't recall right now, the tests. They need custom build rules. So they add custom program. They specify their targets under custom programs. We have very few though, thankfully, because I went and fixed some of those that were added as a custom that don't really require custom. So just the regular makefiles will build. Do you have a question? You're looking puzzled, so I was thinking, yeah.
Can we use some kind of wildcard for test files?
I'm sorry?
Wildcard.
Wildcard. We do some of that handling. There is some of that wildcard handling, but you know,
yeah.
You're saying that to fix wildcard for what?
For test programs extended. Yeah, actually, Kselftest is a collection of the shell scripts, so that it has too many files.
Okay, we can talk about that. Yeah, definitely. If there are some ideas there, we can talk about it. So, relocation case, so when we are running tests in a relocated case, some of these get automatically, all the dependencies get moved automatically. So installation, everything that you need to install, to run from an installed target, they get all installed. So, and then when you do the install, you also, this script gets generated using common framework. So, I mean, I already talked about skip handling. I went and added skip handling, and then to all of the tests, pretty much. All of them are covered, all of these. So we went through this slide already, and then okay, so I have been talking to Anders and then Masami, and then I have a list going in terms of what we want to see accomplished in the next year or next release. You know, it keeps on going, right? So I have a list, and then whoever is interested, just send me email. I'll send the list to you guys. And currently, runtime documentation is one thing that, and then improved, this is improved, so the classification, Osame was talking about a classification of maybe we want multiple categories of skips, so, but my time is up here. So anyway, I will share the list with you guys. Whoever wants, just send me email. And I'm sending it to Anders, Masami, and then Naresh, yeah. Whoever else wants, just, I don't want to flood the mailbox. All right, thank you so much.